Hello friends, now today I am going to discuss series. This is also the part of mathematics, but I am applying the series as a code and we can solve the difficult and complex problem. So let's see the what is the series. Series expansions are an important tools in the many disciplines in computing. So series expansions um, we are going to try to discuss like expansions, and most of the time you can say uh, polynomials with the coefficients given by the derivatives of the function at the point around which series expansions is made. So previous class just we are using here Sympy. So here same procedure, just I have already understand how to variable has been created. So here I am going to create here x and y, there are two variables and one. Then I am going to apply Sympy dot symbols, and now it represent as a x and y, x comma y. So there are two variables, and now just another function f I am going to create here Sympy dot function, and f and with respect to x, to need to the parenthesis and x. And now I am going to create here Sympy dot series, Sympy dot series, and we have already created two. So one is the f, another is x. So let's see, is it working and not working, because we are going to try here create a function like this. So is it possible and is it working and not working? So I hope need to the run other variables is also, let's see, because Sympy has been started from here, so need to modules here. So I didn't try to the modules here, so need to the run Sympy, and another is from the Sympy and import here. So this, because import is Sympy and Sympy dot init printing. So let's see, now I think, yeah, so let's try here. Sympy has not been, so need to the import a Sympy and others. So sympy Sympy dot symbol and Sympy dot this one. So let's see, yeah. So look here, very means don't surprise here. So we can create easily within a seconds. So complex type of series has been generated like this. So this is a way to understand, and we try to do more practice. Now to change the point around which the functions is expanded, and now I want to I specify the x0 argument. So if I write here x0 means, just if you write the x0, yeah, you can say the x0, and x0 will equal to Sympy dot symbol, because I am using the single function, so s as a capital BOL, and now parenthesis inside of this here collisions. So and need to here this type of brackets, curly brackets, and now I am going to x underscore 0. But it is possible to the inside of these brackets. Try copy and try the paste. So now it's alright. Excuse me. So let's see. Now I am going to print here f dot series and parenthesis x comma x0 comma n will equal to 2. So n will equal to means second and okay. So let's see. So I think yeah, it has been created, and x minus x0 dy d eta 1 okay, x tends to x0 till here. So similarly, if you want to remove something, so you can use remove functions. So then don't need to go here. So let's see, just if I write here same series and I want to remove, so let's see remove, so remove 0 parenthesis. So what happened? So we can see the differences of this. So I think REMOVE and is it zeros? I did write here the zeros, but what happened? Add object has no attribute remove 0, because here we also specify n will equal to 2. So I did specify here n will equal to 2 here, right here. So to request a series expansion with the only term up to and including the second order, but no error due to the something the represent like a order object of the O. Order object is useful for keeping a track to the order expansion. So this is not a working, okay, don't worry, means it may be some code has been changed and something, so don't worry, because we are doing the different thing. So we try to search something new, but I also try and I try to solve this problem. So let's see, similarly, just if I write here expansions like a preceding text we are computing as unspecified functions fx. So we can also compute the series expansion to the specific functions and expression, and in those cases like a evaluate and results. So let's see here Sympy dot trigonometric functions like a cos and x dot series and parentheses. So is it possible to, it has been generated simply cos x series, yeah, it has been generated 1 minus x square by 2 plus x to the power 4 by 24 and plus 4 and x to the power 6. Similarly, We can also create here the sine functions, sine series. So same we can write here the sine enhance of sine tan. So let's see, here we can write here enhance of cos sine, and let's try here. So it has been generated like this. If possible to the exponential, so x minus x to the power 3 by 6 and plus x to the power 5 by 120 plus 1. So is it possible also the tan? So you can try yourself tan. And another is the I am going to the expansion exp x. So let's see exp, and so enhance of cos I am going to write here exp. So exp dot series, yeah, so 1 plus x square by 2 plus x 2 by 6 x 4 by 24. So these are way, so we can easily expand. Is it possible to expand here 1 by 1 plus x? Yes, x, if you write here 1 divided by 1 plus x, so just try to write here x by and 1 plus x, so need to the parenthesis 1 and plus x and dot series dot series parenthesis. So let's see, yeah, so it had been printed 1 minus x look like this. So these are the expansions. So we can also write here expressions and cos x minus sin x, so other more expressions. So there is a way to you can express easily any terms. Now I am going to discuss here limits. So this is the most important. So limit, so another means important tool in a calculus is a limit, and which denotes the value of a function as one of its dependent variable approach a specific value of the value of the other variable approach, negative approach or positive infinity. So now if I write here differential d by dx fx and limit h tends to 0, then we can write here fx plus h minus fx by h. So limit are more of the theoretical tools and do not have a many practical applications. As say the series expansion, it is still useful and to be able to compute a limit using Sympy.py. So let's see, I try here Sympy dot limit and bracket start Sympy dot sine x, and now sine x by x, sine x by x here is an identity like this, sine x by x and x, now comma again x comma 0 x tends to. So let's see how do I get. So yes, it has been worked. So we obtained the well-known answer 1. If I put here already in theory we have already understand these things. So same thing if I try to write here f will equal to x comma h and will equal to Sympy dot symbols and x comma h and f Sympy functions also. So x comma h Sympy symbols, and now f will equal to Sympy dot function f. And now I am going to try here another possible. So it is working and not working. So let's see. Just I am going to write here differences def underscore what is this limit will equal to parenthesis f bracket start x plus h and minus fx and divided by h divided by fx and divided by h. So I think fx will be equal to this one and it will be the outside of this. So fx plus h minus fx and divided by h. So this one is the outside of this. Okay. So let's see. Just I think just look here. It's not possible. Just it is working and what happened just. So now I am going to write here differences and it is also working. So this functions has been created. So is it possible to write another function? So if I write here Sympy dot limit and diff underscore limit dot subs bracket start f comma Sympy dot cos and h comma 0 h comma 0. See here, so it has been printed like a minus sin x. Same we can also, if I write the differences limit sub f Sympy dot sin, it has been printed look like a cos. So let's try here. So if I write dot sign. So now it has been printed, look like cos x. So I think we can easily understand, so we can easily solve limits also. So we are using a limit, and now sum and products. Sum and products means sum and products can be the symbolically represent using the Sympy classes Sympy dot sum, Sympy dot product. So we can take an expression as the first argument, as the second argument, and they take a tuple of the form like a bracket, small brackets, n is a tuple, n1 or n2, and where n is a symbol, and n1 and n2 are the lower and upper limits. So if I write here n will equal to Sympy dot symbol, Sympy dot symbols, parenthesis, n, and now integer as a true, comma, integer will equal to 2. Okay, and second variable like a x will equal to something, x will equal to Sympy dot sum, because sum, and now parenthesis 1 divided by 1 divided by parenthesis n and square, this one, now again parenthesis n 1 comma infinity 0 0, here you can see also, and now I am going to print here x. So let's see what happened. Is it possible to has been printed? Yeah. So this one summation intimation has not visible, and but it is start from the 0 and to n minus n will equal to 1 and 1 by n square. Similarly, if you write here x, do it in x dot, we have already discussed, do it parenthesis. So let's see, we can get here output look like this, x dot do it and something. So this is a way to we can also. Next equations, so most of them is in previous class I have already discussed the equation how to write here. So but I would like to solve equation. So let's see here, first like to print something, some solutions look like a b and c. We have a 3 variable a comma b comma c, and this will equal to Sympy dot symbols and now bracket start a comma b comma c, and now I write Sympy dot solve. Now bracket start a x square a into x square plus and 2 to the power x minus 3. Now let's see, because it has been symbols SYM, so I need to write here SYM, A, B and C has been given 3 partitions. Okay, so I don't think here, and A, B and C symbol X. Okay, and SYMPY Sympy dot SYMP over this, right? But what happened? Okay, so I did not think it like that. This way. So you see, it is here. First we move to the so A, and then we need to track double. Okay, so let's see. I hope, yeah, now it has been look like infinity, but simply dot solve I have written. So A and symbols, I think, look here, A and then X square, X square has been given, need to the space here, need to the 2 to the power X and then minus 3 also. Here we need to give here some space. Now because A and B and C has been printed look like this, not infinity, because I am going to write here something, but it has been still look like a infinity. It is not a printing as a equations. So don't worry, sometimes just some bugs has been changed and something. So let's see now, if you want to create like a linear algebra. So the linear algebra means it is another fundamental branch of mathematics which is important applications throughout the scientific and technical computing. So but I try to solve in the next class the linear algebra. So I write to the some questions like a transpose, adjoint, trash, dot, determinants, inverse, LU decompositions, LU solve, QR decompositions, diagonalized, normalizations, null space, rank, singular value, solve. These are the basic, very important. So I try to solve in the next class the linear algebra. Then we will try to discuss the other. Thank you. I think someone will be helpful